B about the x-axis, and C about the line y equal to 8, and finally D about the line x equal to 2. So there are 4 parts for this problem. Now to begin with, we need to figure out that area. What is that area enclosed by these graphs? Y equal to 2x squared. Well, let's draw the graphs of this. Now you do that on your calculator. Y equal to 2x squared, y equal to 0, and x equal to 2. Those are the graphs that generate that area. Now tell me, what is y equal to 2x squared graph look like? That's right. This is the graph of y equal to 2x squared. Where is y equal to 0? Y equal to 0 is the x-axis. That's right. So this is y equal to 2x squared. This is y equal to 0. And what else? X equal to 2. What is the graph of x equal to 2? There you go. That's x equal to 2. And the area enclosed by these 3 graphs is this area. There you go. Now, first of all, we need to revolve this area about the y-axis and find the volume. Can you figure out if this whole area is revolved about the y-axis, what kind of a solid shape do you generate? Picture that in your mind. Alright, so remember our axis of revolution is the y-axis, and in order to find the volume we of course take an area dA, and always when you take the area dA for the disc and washer, that area dA must be taken at right angles to the axis. So we take a strip of area dA of width dy perpendicular to the y-axis. So here we have that area dA of width dy. Now, remember, when you want to revolve about the y-axis, the functions need to be functions of y, because the distances that you measure from the y-axis is called x equal to. The functions given to you are y equal to. So this y equal to 2x squared, you need to write it as x equal to something. Now tell me, y equal to 2x squared, can you express that as a function of y? What do? Solve this for x. And what does that give you? It will be solve for x first, x squared equal to y over 2. Therefore, x equal to plus or minus square root y over 2. We take the positive part. So x equal to square root of y over 2. This function is now f of y. You see, originally we were given f of x equal to 2x squared. And that is the same as f of y equal to square root of y over 2. I hope this skill is something that you have now mastered. You can see this is the graph of y equal to 2x squared. Express that as a function of y by solving from that equation for x. You get x equal to square root y over 2, or f of y equal to square root y over 2. That is this function graph. That means this distance equal to f of y. So this distance equal to f of y. What is this distance? If this is x equal to square root y over 2, then this distance is x equal to 2. Is that right? This line is called x equal to 2. That distance is x equal to 2. So g of y equal to 2. This is the graph of g of y equal to 2. So we have both the functions expressed as functions of y. Alright? Now, where is the point of intersection? You have f of y and g of y meets at this point. In other words, f of y equal to g of y, we need to solve for this. And when you revolve this area, this dA about the y-axis, what we're going to generate is a washer. A washer which has a hole in the middle. That's right. So this is your f of y, in other words, f of y equal to square root y over 2 is actually the radius of the hole. That is this radius. F of y equal to square root y over 2. And what is the outer radius? The outer radius is g of y equal to 2. So we have the outer radius and the inner radius. The uppercase R and this is the lowercase r. So to find c and d, what do? We solve f of y equal to g of y. F of y equal to g of y. And can you solve and tell me what the value of y is here? Square root y over 2 equal to 2. Square both sides. You get y over 2 equal to 4, or you get y equal to 8. That's right. So this is y equal to 8 and this is y equal to 0. That means the position of this element area can change from y equal to 0 all the way to y equal to 8. That's right. So y equal to 0 is the lower limit, y equal to 8 is the upper limit. Now, when dA is revolved about the y-axis, we generate this washer of outer radius big R, which is 2, is that right? And the inner radius small r, which is your f of y equal to square root of y over 2. So big R equal to 2, that is your outer radius, that distance. That's right. And the inner radius is square root of y over 2 is this. Alright, once you have all this information, it is now simple. Alright, now the volume dV of the washer, can you recall that expression? The volume dV of the washer is pi times big R squared minus small r squared quantity times d by the thickness of that disk. So that would be dV equal to pi times big R squared minus small r squared times dy. This is not supposed to be dx, it's supposed to be dy. It can be dx only when you revolve it about the x-axis. So correct that printing error there. So that will be pi times big R squared is 2, so that will be 2 squared minus small r is square root y over 2. That is square root y over 2 all squared dy. You can see another printing error there. This is 2 over y. It must be y over 2. So that will be pi times 2 squared is 4. Square root y over 2 squared is y over 2 times dy. And now we have dV. This is our dV. And in order to find the total volume obtained by revolving this whole area about the y-axis, we integrate dV from y equal to 0 to y equal to 8. And therefore that will be integral 0 to 8 pi times 4 minus y over 2 dy. Pi of course will come out and you can integrate this quantity now. That'll be pi times integral 4 dy is 4y minus integral y over 2 dy is, what is, you see y over 2 is 1/2 y. That will be 1/2 times integral y dy is y squared over 2. And the two 2's on the denominator will give you a 4 on the denominator. So integral y over 2 dy is y squared over 4. And the lower limit is 0, the upper limit is 8. Again, the lower limit will not give you anything because 0 will make both these 0. We need only the upper limit. That will be pi times 4 times 8 minus 8 squared over 4. That will be 16 pi. That is the volume generated when this area is revolved about the y-axis. Okay, I'm sure you can do that now on your own. If you generate this area about the x-axis, what will be the volume generated? Now, in order to revolve this area about the x-axis, how do we take the element area? The element area that we take must be at right angles to the axis of revolution. So let's